Alright, so this question reads, from the 1st through 7th of next month, 7 nurses, F, G, H, J, K, L, and M, will each conduct one information session at a community center. Each nurse's session will fall on a different day. The nurse's schedule is governed by the following constraints. Alright, so we have our nurses, F, G, H, J, K, L, and M. And we know that we're going to place them in an order 1st through 7th for their information sessions. So 1, 2, 3, 4, 5, 6, 7. All right, now let's go to the rules. Rule number 1. At least 2 of the other nurses' sessions must fall in between Heaney's session and Moreau's session. Okay, so we don't know whether H or M is going to be first, so we're going to have a binary here, HM, and then I'm going to place an arrow, and then we're going to have 2 spots, and then another arrow, and then the binary MH. And the point of the arrows is to show that this isn't a block. This isn't HM2 and then MH, because there could be more. We're saying that this is at least 2 spots. So that's what this is going to depict. All right, let's go to rule number 2. G's session must be on the day before K's. All right, easy. So that's going to give us a block. G is before K. And that means that K isn't going to be first, and G isn't going to be 7th. Rule number 3. J's session must be on a later day than M's. Okay, simple enough. 3, M, and then J. So we know J is not first and M is not last. Rule number 4. F's session must be on an earlier day than K's, but on a later day than L's. All right, so rule 4, we have L, and then F, and then K. So we know that K has 2 nurses before her. So that means K can't be first, which we already have. And we know that means also that K can't be second. Likewise, L has 2 nurses after her, so L can't be last and L can't be 6th. We also know that F has 1 nurse to the left of her and 1 nurse to the right of her. So that means that F cannot be first and F cannot be last. But we also can combine rules 2 and 4 like so, where we have L, F, and then our GK block. And this shows us that K has 1, 2, 3 nurses before her, so that means that K can't be third. Likewise, it shows us that L has 1, 2, 3 nurses to the right of her, so that means that L can't be 5th. And this also tells us that F has 1, 2 nurses to the right of her, so F also can't be 6th. Likewise, since G has 2 nurses to the left of her, that means that G can't be first and G can't be second. All right, so now moving on to the last rule, rule number 5. L cannot conduct the session on the 2nd. Okay, so we have L not second. So L not here. All right, so what are the deductions we can make? Well, we see that we can't have K, J, F, or G, and that leaves us with 3 nurses left for the first session. So that's H, L, and M. Likewise, we have 4 nurses that can't have the last session. So that leaves us with H, J, and K. Now, the one last thing I want you guys to notice, remember, we're always looking for the most restricted variables. And who is the most restricted nurse? Well, if you notice, L seems to not be able to be in a lot of sessions. L can't be 7th, L can't be 6th, 5th, or 2nd. So at this point, that means that L is either going to be first, third, or fourth. So let's try out fourth, since fourth doesn't seem to have any restrictions at this point. So what happens if L is fourth? Okay, well, we know that F, G, and K have to be after L, and if L is fourth, there's only 3 places, meaning we have to have F, G, and K, and that leaves us with 1, 2, and 3. But remember, rule number 1 tells us that H and M have to be separated by at least 2 nurses, and there aren't enough spaces for that when L is fourth, meaning L cannot be fourth. So L can't be fourth. That means we're down to L being first or third. So let's write it out on the side. Our first option will have L being first. Now, what do we know if L is first? Well, we know F, G, and K are after it. We know everything's going to be after it. We can't really deduce anything else from L being first. Now, let's try out L being third as our second option. So again, we know that F, G, and K are going to be after L. So we have 1, 2, 3, 4 spots for F, G, and K. Now, what if we were to place our F, G, K string along with J to the right of L? That would leave only H and M, and they would have to go here. But that goes against rule number 1, because remember, H and M have to have at least 2 nurses separating them. Therefore, that means J can't be to the right of L. Remember, we placed J there to see if it'll work because we already know that F, G, and K have to be to the right of L. So that means J is going to be to the left of L, and since M is to the left of J, we're going to have M, J, and then we can have either F or H here, because remember, we can't have K and we can't have G because K has 2 nurses to the left of it. So again, K can't be here either. And G has 1 nurse to the left of it. And I'm saying that because we're saying L is already there. So between L and G, there's still 1 nurse, meaning G can't be immediately after L. Likewise, that means that F and G can't be last. So that leaves us with K, H as our binary. And since F has to have G, K after it, that means F also can't be 6th. So that leaves us with the options of F, H, and G for 5th, and K, H, and G for 6th. Alright, so the last thing we have to note is since these are our only 2 options, since L can either be first or third, that means we have to change our setup because remember originally we said we could have H, L, or M be first, but now we know that we can only have L or M be first. So we'll place L, M here. So those are all of our deductions. We have our setup and our rules, and now we're ready to hit the questions.